Hello everybody. I can tell you're ready to get your math on, so we are going to talk about some range and mean deviation. Range is something you've probably learned about previously, but mean deviation is something going to be a little bit new. So we're going to jump right ahead if my computer decides to work. So range and mean deviation. Statistical measures we look at before gave an idea of where the data was centered at. A measure of dispersion is used to determine how close together or spread out a set of data is. So you might have a bunch of numbers all clustered together with an average of 10, and then you might have a bunch of numbers really spread out that still have an average of 10. So dispersion tells you how close together or how spread out things are. So if we look at these two sets of numbers, for example, we have 10, 24, 27, 29, 30, 31, 33, 36, and 50. I know I said those really fast, but they're on your page so you can look at them at your own pace. The second set has 10, 12, 16, 24, 30, 36, 44, 48, and 50. Looking at them really quickly, you notice that both of them have 9 numbers in them. Okay, so they have the same amount of entries in them. If you actually average the first set out, you would get x bar, or the mean, equals 30. If you average the second set, you get the same thing. X bar is also 30. So they both have a mean of 30. If you go through and look at each of the sets, you'll notice that the two middle numbers, the medians of both sets, are also 30. So it doesn't really help us to look at the measures of central tendency here, because both of these data sets are identical. They have 9 numbers, they have an average of 30, and they have a middle number of 30. So just by looking at this, we would think they're the same. But if we look a little closer, we can see that the first set is closer together. It only goes from 10 to 50 with 2 outliers on each side. 24, 27, all the way up to 36 are pretty close together. The second set, again, goes from 10 to 50, but the numbers in between are more scattered throughout there. 12, 16, 24, all the way up to 48 are separated out a little bit more. So the first set is closer together with the exception of 1 low score and 1 high score. The most basic measure of dispersion is the range. Range is something you've talked about in probably 6th, 7th, and 8th grade. It's found by subtracting the highest number and the lowest number. So you're doing the maximum minus the minimum. The problem with this is that it can be influenced by one really high or one really low number. So a set of data might be really close together with an outlier on either side, and it'll give you the same range as another set of data that are more spread out, just like data set 1 and 2 just a second ago. Instead, a better measure is the mean deviation. Now, this is something new. It measures the average distance each piece of data is from the mean. So it tells you how far deviated you are from the average. There's a formula for this. And there was a short reading there about population formula versus sample formula. You should read that on your own. So to find the mean deviation, we use the formula for the population. The formula is going to be, it goes back to this crazy little alien letter, sigma, and it goes from when I is 1 up to however many you have, the absolute value of each term minus the average, the whole thing divided by n. Okay? For a sample, it's just a little bit different. It's going to be the sum from I equals 1 up to however many you have again, the absolute value of each term minus the average, all divided by n minus 1. Sorry, that ran into the corner thing there. For the most part, you are only going to have to worry about the population. That's the one that you should focus on. Okay. Now I know this looks confusing. If you make a table, it's extremely easy to figure out. It is a lot of work, but it's easy work compared to some of the other stuff that we've done. It's a lot of work, but it's confusing and difficult. So, looking at the first example here, it says the average number of hours worked in a week by a construction worker were 36, 40, 40. We're actually going to change one of those. Change that second 40 to a 45. Okay, change that one to a 45 or it's not going to work out nicely. That's a typo. So 36, 40, 45, 42, 37, 38, 40, 44, and 38. We want to find the range and the mean deviation of the number of hours worked. Well, the range is pretty straightforward. You're going to do the smallest number and the largest number. So the biggest number we have there is going to be 45. The smallest number we have there is 36. So we're going to do 45 minus 36, and you'll end up with a range of 9. To find the mean deviation, it's a little more work. So we want to start by figuring out what each of our data entries are. So our x sub I. Well, each data entry we have are 36, and they don't have to be in order. 40, 45, 42, 37, 38, 40, 44, and 38. So those are each of our data entries. We want to find out what the average for this entire thing is. So you should add all those up and divide them by 1, 2, 3, 4, 5, 6, 7, 8, 9. So add them up and divide by 9, and you'll end up with an average of 40. X bar equals 40. So that's going to be our next column, X bar, which is 40 for every single one of them. So fill that in all the way down. And we're ready for our next column. This is going to be the first part of that formula. So each entry minus the average. So what you're really doing here is you're saying 36 minus 40, 40 minus 40, 45 minus 40. You're subtracting each one of these all the way down. So 36 minus 40, that's negative 4. Then we have 0, 5, 2, negative 3, negative 2, 0, 4, and negative 2. You want to make a column for the absolute value of that. So now these are all going to change into positive. So 4, 0, 5, 2, 3, 2, 0, 4, and 2. And I know I compressed that a little bit because I need a little room down at the bottom. And what you're going to do is add all those up. So if you add 4, 0, 5, 2, 3, 2, 0, 4, and 2, put them all into your calculator, use your fingers, you might need your toes for that one, and you will end up with a total of 22. Again, this is a lot of work, but we haven't really done anything difficult. We've done some subtraction, we found some absolute values. That's it so far. So the formula for mean deviation is you're going to take that number that we just found, so 22, and you're going to divide it by how many there are altogether. So if you notice over here, there are 9 total entries. So that's going to be 22 divided by 9. And if you put that into a calculator, you end up getting 2.4. So our mean deviation for that set of data is 2.4. What that means is that on average, each of those numbers is 2.4 away from the average of the whole set. I know that sounds kind of confusing. We will talk about it a little more in class tomorrow. I want you to try this next example on your own because it doesn't require a scientific calculator. All it requires you to do is add, subtract, multiply, and divide. So any 4-function calculator, including the one on your phone, will work. So it says an English teacher recorded the number of misspelled words in 25 essays. Calculate the mean deviation. Now this confused a couple people the other day because this is actually a frequency table. What this means is that this first set here is the number of errors, and this second set is how many times that number came up. So if you were to list out this entire set, you would have 12 once, you would have 7 3 times, you would have 6 twice, you would have 5 5 times, and so on and so forth all the way down the rest of the list. So if you need to write them out, that's fine. When you get into class and do have a scientific calculator, you can use list 1 and list 2 to find the average. That'll make it a little easier. But if you don't remember those steps, you can always just add up and divide by how many there are. So go ahead and try and find the mean deviation on your own for that. We're going to go over it first thing in class tomorrow. I hope you have a wonderful evening.